Good morning, everybody. My name is Olena Kirilenko, and I'm Associate Professor at the Department of Software Engineering, National Airspace University. Let me start by saying thanks to all of you for the interest in this presentation. First, I will begin with an overview of the method of constructing individual educational students' trajectories according to European E-Competence framework. Then, I will present the results of the proposed method according to the European E-Competence framework for software engineering specialty. And lastly, we'll make a conclusion with the main recommendation. In our volatile, intimately connected and dangerously vulnerable world, educational system must be anticipative because the future is far from a linear extension of the past. There is a new emerging sustainable learning and education philosophy of learning as a fundamental principle of the sustainable curricula building with appropriate methods of learning and teaching. However, improving students' knowledge, skills, and competence without a clear plan and goals as how that a future bachelor, master, or PhD will correspond to the organizational needs of an employer generally has minimal effect. Students should understand the general learning objectives and not learn in fragments without any apparent purpose. To define a common language, to write a clear and harmonized curriculum in support of the European digital single market, we use the European E-Competence framework and the European ICT professional role profiles. Incorporating the competences of the European E-Competence framework as the main component of profile descriptions, the 30 ICT professional role profiles provide a generic set of typical roles performed by ICT professionals in any organization, covering the full ICT business process. E-Competence framework and ICT professional role profiles provide a working platform for creating professional standards for training software engineers at universities. The ECF has provided to be very useful in the process of curricula design because one of the critical challenges of effective curricula design is managing how different stakeholders communicate and cooperate in designing curricula that meet both educational and employee objectives. There are some approaches to the curriculum building. Some of them you can see on the slide. The main disadvantage of these approaches is educational standards and training programs at various levels are often not harmonized, based on incompatible competency systems, which leads to problems. It does not allow ensuring the continuity of educational problems at various levels, the possibility of reducing the learning duration, and supporting individual educational trajectories of students. The purpose of the article is to present the method of constructing individual educational students' trajectories of the process of the professional training of future software engineers in Ukrainian universities. Implications for curriculum design in relation to curriculum design. Student-centeredness includes the idea that the students have choice in what to study and how to study. On this slide, their input assumptions and limitations of methods. The target competences for training specialists in software engineering must provide training for profiles, developer, test specialist, and digital media specialist, because these profiles fully meet the qualifications of degree specialist in the development and testing of software by the National Classification of Professions in Ukraine. The target competencies that developers, digital media specialists, or test specialists may possess are limited to the third level of ECF, which corresponds to the bachelor's level both in the European qualification framework and the law on higher education of Ukraine. The choice of further educational paths should be justified proceeding first of all from the desired target profile. The criterion for the validity of the choice of an educational trajectory is the minimum difficulty in acquiring new necessary competencies and increasing the level of competencies already achieved at the previous level of education. In our opinion, this complexity can be qualified by summing up the number of new competencies required, taking into account their level and the number of new deliverables for which the future graduate will be responsible. The proposed methods for the set constructing of the software engineers' educational trajectories in Ukrainian universities uses graph theory. The initial data are the interrelations matrices of the ICT profiles E-Competences and ICT profiles deliverable. In the mathematical representation, these tables define two bipartite graphs mapping formula. The proximity function between any two profiles and S and T we define as distance in an undirected graph. The second formula, where A coefficient that allows controlling the importance of proximity metric according to the common competences, relative proximity metric according to shared deliverable. The complexity function of the transition to a new profile in the presence of competences of the existing profiles we introduce as a distance in a directed graph, formula 3. The assumption that training is carried out in a consistent progress through the educational levels leads to a search all possible pairs S and T within a stepwise education system with the suggestion that these pairs must satisfy the following condition, formula 4. We introduce the reachability matrix of the next target profile starting with the existing one. In graph theory, reachability refers to the ability to get from one vertex to another within a graph. A vertex S can reach a vertex T, and T is reachable from S if there exists a sequence of adjacent vertices, for example a path, which starts with an S and ends with a T. Taking into account constraint 4, the reachability matrix we present as formula 5. Moving to our next slide. The method of constructing individual educational trajectories set and curricula set as a result in a sequence of following steps. Step 1. First, clustering profiles as the process of ordering of profiles, graph structure into relatively homogeneous groups, where the proximity function between any two profiles is calculated according to 2. We use the modularity metric proposed in the paper, 22 for clustering. The metric value lies between 0.5 and 1, calculated by the formula 6. Then, the reachability graph describes the ability to get from obtained profile to the next one by educational level with quantity estimation of the step complexity. The reachability graph is constructed by using 5 and is become a background for building individual educational trajectories set. Step 3. The curricula set is constructed using individual educational trajectory set. The start point for each curricula building is the needing competences for goal profile, knowledge, skill examples, catalogued in the ECF. Now, let's turn to our results. We performed a profiles clustering from ECF from taking into account only the quantity of common competencies required for each pair of profiles. As a result, we got 7 closely related groups, figure number 1. Each group has its color, and the line thickness between each pair of profiles is proportional to the number of shared competencies. The aimed group includes next roles: developer, digital media specialist, tech specialist, DevOps expert, system administrator, network specialist. This slide shows grouping of profiles by deliverables, outcomes, proximity principles with from number 2 give the partially different result, figure 2. A deliverable, according to the ECF, is the predefined result of a task in a job context. Deliverables describe typical outcomes of a solved task in terms of accountable, responsible, or contribution. When clustering according to the proximity by deliverables and outcomes, the aimed group includes next rows presented on the slide. All recommended trajectories for achieving the desired profiles for software engineering are presented on this slide. The line thickness characterizes the number of competences achieved at the previous level that will be claimed in the next one. That is, the thicker the connecting line, the easier it will be to achieve the target profile. Each person selects their trajectory personally. Therefore, the mathematically solved problem belongs to the class of tasks in which it is required to list all implemented trajectories for future choice. After that, the student might choose his learning path, and the university must build the educational programs necessary for the implementation of the required trajectories. This slide includes details, recommendations, individual educational students' trajectories, starting from the software engineering profiles, developer, digital media specialist, test specialist, which are available from junior bachelor level. Next slide contains reference information about deliverable and competencies, which must be formed or improved during the transition from systems architect role profile to digital transformation leader role profile. Further development of the work is planned in the practical implementation of interactive online assistant, which will formulate recommendations for the student on the choice of disciplines, forming a set of trajectories from the already achieved level to the target one that the student will choose. Practical implementation, structural and logical scheme of the bachelor's degree problem. Choose your learning trajectory, you can see on the slide. Finally, may I remind you some of the main points we've considered. The paper focuses on and proposes the semi-formal method of constructing individual educational students' trajectories of the process of the professional training for future software engineers in Ukrainian university. The method for the student-centered learning conception support presented by the authors was developed using graph theory. The set of educational paths that the student is invited to choose corresponds with the requirements of the IT companies and provide the student with the opportunity to choose his or her educational path for the level of education legally enriched in Ukraine. Ukrainian universities can use the proposed educational trajectories of the professional training of future software engineers for curricula and syllabus preparation. The practical development of this work is an interactive online assistant that will recommend to the student the choice of the educational path from the already achieved level to the target level, which the student will choose. Many thanks for your attention. Any questions so far?